Okay, so real quick, there are only a few kinds of metals that can become magnets. Iron is the most common as it's cheap to produce and will keep its magnetic field for longer, but nickel or cobalt can also hold magnetic fields, as well as a few man-made metallic alloys. To see what is actually creating the magnetic field, we have to look at the atoms that make these metals up. This is what we currently believe an atom looks like. Yeah, I was taught the more popular model in school as well, since at the time we couldn't see much more than this. Magnetism is created by the flow of electricity, specifically electrons. All electrons spin in one direction or the other. This spinning motion creates a tiny magnetic field around the electron, as the motion of any amount of electron-based energy will create an electromagnetic field. Therefore, these spinning electrons will have a south and a north pole, just like the magnets they make up. The magic happens when a bunch, if not all of the electrons in a metal are lined up north to south pole in one specific direction. This mass lining up of all electrons in metal is caused both naturally and artificially. In nature, magnetized iron and a bit of oxygen, called magnetite, becomes magnetic when the metal is molten within Earth's core. In this molten state, the electrons can more easily align with all of the other free-moving electrons and atoms that also have tiny magnetic charges within the molten metal. But humans can create magnets themselves by either rubbing a piece of iron against an already existing magnet, which will align the electrons within that chunk of iron into a weak magnet, or we can expose metal to an electric field, which will also do the job. A magnet is strongest when the vast majority or all of the atoms are aligned within so that their electron poles are linked. This creates a sort of highway for loose electrons to flow through the metal in a closed circuit, strengthening the magnetic poles of the electrons with an additional contained electromagnetic field created by those flowing electrons. The more electrons both aligned and flowing through a substance, the stronger of a magnet that substance becomes. Now remember that not only is our planet's core made up of primarily iron, but that iron is both molten and flowing. This creates an ultra-strong magnet that is powerful enough to divert incoming radiation from space, making a perfect home for our delicate life to enjoy. There are far stronger magnets out there in space. Jupiter's magnetic field, if it were visible to the naked eye, would be 15 times larger than the Sun. Earth's magnetic field measures as a 0.65 Gauss, which is just the unit used to measure magnetic fields, while Jupiter's field measures in at 4.2 Gauss. But more extreme places with mind-bending magnetic fields exist elsewhere in the universe, such as around black holes with a 30 Gauss field, about 50 times stronger than our own. But the strongest magnets ever discovered have been around magnetars, which are rapidly spinning neutron stars created after a star collapses and isn't massive enough to become a black hole. These magnetars have fields measuring in at 10 to the 15 Gauss, which is a 10 followed by 15 zeros. It is a field almost 1 trillion times more powerful than Earth's, and if you got within 1,000 miles of one, the iron within your bloodstream would be ripped from your body. Get close enough and even the bonds that keep your atoms together begin to break down. A magnetar is already extremely hot, dense, and massive, all aspects that could kill you in the blink of an eye, but its magnetic field alone can liquefy matter. The strongest magnet ever created by humans is the MagLab's direct current magnet. It was created by the National High Magnetic Field Laboratory in Tallahassee, Florida, and can sustain a field with the strength of 450,000 Gauss, about 45,000 times stronger than Earth's field. The magnet itself is 22 feet tall and weighs 34 tons. The strongest magnetic field that humans could ever create is one with a strength of 500,000 Gauss, as after that point the field is strong enough to start tearing matter apart, which includes itself. So that's how magnets work, as well as a few examples of extreme magnets in the known universe. Thank you for watching, and I hope you learned a thing or two. Please subscribe to stay up to date with my future uploads, and I hope you all have a wonderful day.